In this video lesson, we will continue learning about logarithmic equations. In my video lesson, Logarithmic Equations 1, we learned about several types of log equations, and it also learned that it's very important to check your answer. Here we're going to learn how to use properties of logs to help us solve these log equations. So here's our first example. Let's say we have log base 12 of x plus 1 equals log base 12 of 4x minus 2 minus log base 12 of 2. So earlier there was just one log on each side, and then what mattered was just what's inside of the log. In this case, we do have the same base, but we have 3 logarithms total when we only want 2. So what do? We use the properties of logs to change the expression on the right side to just 1 log. That is, remember that when we subtract 2 logs, we divide. So we have 4x minus 2 inside of 1 log minus log base 12 of 2. So we have 4x minus 2 all over 2. And that simplifies to 2x minus 1. So our original equation becomes log base 12 of x plus 1 equals log base 12 of 2x minus 1. Alright, well now we can do the same thing as before. We look on the inside of the parentheses, on the inside of the logs, and we get x plus 1 equals 2x minus 1. And what does this equal to? Well, we can simplify it, and we just get that x equals 2. So our answer is x equals 2, but we still have to make sure that when we plug in x equals 2 that everything works out fine, because remember, you can't take the log of a negative number. So let's try it out. I get log base 12 of 3 equals log base 12 of 4 times 2 minus 2, and also minus log base 12 of 2. And on the right hand side, 4 times 2 minus 2 is 6, and we're subtracting log base 12 of 2. And we again use the division rule. Division and subtraction go together. We have 6 over 2, so it's log base 12 of 3. So the right hand side is equal to the left hand side, and we're all good. And we're not taking the logs of any negative numbers either. Alright, well let's do another example. Let's say we have natural log of e to the x minus natural log of e to the 6th equals natural log of e to the 5th. So natural log, just remember, is log base e. And this actually helps us out a lot, because if we look at how we want to simplify this expression, we have very many logs, but they also have powers on the inside. And these powers on the inside means that we can factor them outside of the logarithm, because remember, that is one of the properties of logarithms. So ln e to the x is the same as x ln e, and similarly for ln of e to the 6th and ln of e to the 5th. But then remember, ln of e, remember the question, to what power do you take e to get e? Well, that power is obviously 1. So this whole thing simplifies to x minus 6 equals 5. So then x equals 11. In this case, I will not check whether or not the answer is right. You can do that on your own. And we'll just move on to the next example. Alright, in this example, we will take log of x plus 2 equals log of 2 minus log of x plus 3. So we obviously want to somehow use the rules of logs to simplify this. So first of all, I just want both of the logs with x's to be on one side of the equation. So I added log of x plus 3 to both sides. So now we get an equivalent expression, log of x plus 3 plus log of x plus 2 equals log of 2. Now we'll use the rule of multiplication. When we add logs, we multiply their insides. So I get log of x plus 3 times x plus 2 equals log of 2. Now we only have one log on each side, and it's got the same base. So we can do the same thing as before. All we need to do is solve x plus 3 times x plus 2 equals 2. Well, this is actually just a quadratic equation. For more details on how to solve quadratic equations, there are several video lectures that I have made that you can find. So here's how we keep going from the original. We FOIL, get x squared plus 2x plus 3x plus 3 times 2 is 6. And that equals to 2. And then we combine the like terms. X squared and 5x plus 6 is equal to 2. And of course, we want to make a 0 on one side of the equation, so we subtract 2. So we get x squared plus 5x plus 4 equals 0. This quadratic equation factors. I'm not going to go into much detail explaining how to factor it, but I will factor it here for us, just for simplicity. So I get x plus 4 times x plus 1. If you want more info on how to factor, again, you can find it in my other video lessons. So we have x plus 4 equals 0 or x plus 1 equals 0. In the first case, x equals negative 4. In the second case, x equals negative 1. But don't forget, it's really important to check your answers. In this time, there are 2 answers for us to check. So I'm returning back to our original expression, and I'm just going to erase it and rewrite it right now. At first, we had log of x plus 2 equals log of 2 minus log of x plus 3. All right. So if we plug in negative 4 as our first choice, and get log of negative 2 equals log of 2 minus log of negative 1. But we're taking the logarithm of a negative number here, twice even. We're not allowed to do that, so we can't say that these numbers are equal, because in fact they aren't numbers. You can't take the logarithm of a negative number. That immediately excludes negative 4 from being an answer. So negative 4 is definitely not it. We cannot write negative 4 to be a solution. But we still have negative 1 to try. So what happens if we plug in negative 1? I get log of 1 equals log of 2 minus log of 2. Well, hey, both sides simplify just to 0. So we get 0 equals 0. And that's definitely true. So x equals negative 1 is indeed a solution. And it's the only one. But anyway, that's all for now, and thank you for watching this video lecture. I hope it helped.